KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class, we start with problem number 25. Okay, see here. First, see the problem number 25, then we will discuss 26 and 27. Right, see here. So, in this problem, find the number of photons emitted per second. Find the number of photons emitted per second by, it is what, megawatt transmitter of 10 kilowatt power, 10 kilowatt power emitting radio waves of wavelength 500 meters, of wavelength 500 meters. Okay, right. So observe carefully, this is what A, it is A and it is B. So in A, he is asking to find the number of photons emitted per second by a megawatt transmitter of 10 kilowatt power emitting radio waves of wavelength 500 meters. Right. Next, B, see here. Find the number of photons entering the pupil of our eye. Find the number of photons entering the pupil of our eye per second corresponding to the minimum intensity, of white light that we humans can perceive, right? So this is the general life situation, for example, when we stand on the earth, right? So the light photons are entering into our pupil, no? So how many number of photons are entering the pupil of our eye per second corresponding to the minimum intensity of white light that we humans can perceive is approximately equal to 10 to the power of minus, right? 10 to the power of minus, see here, the value they have given, that is what, 10 to the power of minus 10 watt per meter square, 10 to the power of minus 10 watt per meter square. Okay, see here. So observe carefully, 10 to the power of minus 10, 10 to the power of minus 10 watt per meter square. Okay, full stop. Take the area of the pupil, take the area of the pupil to be about 0.4 centimeter square and the average frequency of white light to be about 6 into 10 to the power of 14 hertz. So please keep in the mind the values what they have given. One is intensity, minimum intensity of white light as 10 to the power of minus 10 watt per meter square, and another one is area of the pupil to be about 0.4 centimeter square, and then average frequency of white light to be about 6 into 10 to the power of 14 hertz. Right. Now first we are going to discuss A. This is what A, then we will go for B. See here, first A, power of transmitter is 10 kilowatt, so 10 into 10 power 3, that is equal to 10 power 4 watt. Next, total energy emitted per second. See here, before, see this, so whatever he is saying according to the question, right? According to the question, see here, so total energy emitted per second is equal to power into time that is equal to 10 to the power of 4 watt into 1 second. See, already power they have given 10 kilowatts. I think you understood. 10 kilowatt means 10 into 10 power 3. So 10 into 10 power 3 means 10 power 4 watt. So that only we have written here 10 to the power of 4 watt into time is 1 second. Time is 1 second. So then finally total energy emitted per second is equal to 10 to the power of 4 joules. Now we are going to calculate energy of one photon. Energy of one photon is equal to, you know this formula E is equal to h nu, that is equal to hc by lambda. You substitute h value 6.63 into 10 to the power of 34, right? And then it is what, minus 34 6.63 into 10 to the power of minus 34 into 3 into 10 to the power of 8. 3 into 10 to the power of 8 divided by 500 joules. 500 joules, okay? That is what here. After that we have to find, here it is number of photons emitted per second, capital N is equal to total energy emitted per second divided by energy of one photon. Energy of one photon. That is equal to, we have to substitute the given values. So one is 10 to the power of 4 into 500 divided by 6.63 into 10 to the power of minus 34 into 3 into 10 power 8. 3 into 10 power 8. This is what the energy of one photon. Here we calculated. Here we calculated in terms of SI unit, joules. So that is 6.63 into 10 to the power of minus 34 into 3 into 10 power 8 divided by 100. That value we are writing here because it is energy of one photon, no? And this 500 will goes to the numerator, then it will be here, and total energy emitted per second already we calculated, which is 10 to the power of 4. So by substituting all these things, if you complete this calculation, mathematical calculation, the answer will become 2.51 into 10 to the power of 31. 2.51 into 10 to the power of 31. So these many number of photons will emit per second. That only he is asking, no? So in question number 25A, he is asking to find the number of photons. So that we found as 2.51 into 10 to the power of 31 photons emitted per second. Emitted per second. Next, B. In B, he is asking to find the number of photons entering the pupil of our eye per second. Per second corresponding to the minimum intensity of white light. So this is the intensity they have given, and this is the average frequency of white light they have given, and area of the pupil as 0.4 centimeter square. See here, minimum intensity I is equal to 10 to the power of minus 10 watt per meter square, and area of the pupil we are taking in SI units, that is 0.4 into 10 to the power of minus 4. As it is 0.4 centimeter square, that we are converting into meter square, 0.4 into 10 to the power of minus 4 meter square. Next, average frequency of white light, it is 6 into 10 to the power of 14 Hz. And then energy of the photon, energy of one photon, E is equal to h nu. H value is 6.63 into 10 to the power of minus 34, but new value given here, no? That is 6 into 10 to the power of 14 Hz. So finally we are getting energy of one photon as 4 into 10 to the power of minus 19 joule. 4 into 10 to the power of minus 19 joule. Now see here, let n be the number of photons crossing per square meter area per second. Let small n be the number of photons crossing per square meter area per second. Then what about intensity? Now intensity is equal to energy incident per square meter per area, right? Energy incident per square meter area per second. So second means indicating the time. Energy incident per square meter area per second, then that is equal to total energy of n photons. That is equal to total energy of n photons, that is equal to n into energy of one photon. N into energy of one photon. So that what can we write? Therefore n is equal to intensity divided by energy of one photon. Okay. You just see by step, so this information we already know, but here we are applying. For example, if we assume a small n as the number of photons crossing per square meter area per second, at the time intensity is equal to energy incident per square meter area per second, that is equal to total energy of n photons is equal to n into energy of one photon. Now we are writing n as a subject, that is what number of photons crossing per square meter area per second. So intensity by energy of one photon, intensity already given, energy of one photon we calculated as 4 into 10 to the power of minus 19 joules. So this will be the number, that is 2.5 into 10 to the power of 8. 2.5 into 10 to the power of 8 per meter square per second. So what can we write here at last? Like to give conclusion for B, the number of photons entering the pupil of our eye per second, the number of photons entering the pupil of our eye per second is equal to n into area of the pupil, n into area of the pupil, and area of the pupil given in the question, that is what here 0.4 centimeter square. So finally this value 2.5 into 10 to the power of 8 into 0.4 into 10 to the power of minus 4, that is equal to 10 to the power of 4 per second, 10 to the power of 4 per second. So per every second these many number of photons are entering into our pupil, right, pupil of eye. So which is 10 to the power of 4, 10 to the power of 4 means 10,000, okay, right. Next question, question number 26. Ultraviolet light of wavelength 2271 angstrom unit from a 100 watts mercury source irradiates a photocell made of molybdenum metal, full stop. If the stopping potential is approximately equal to 1.3 volt, estimate the work function of the metal, that is one thing. And after that he is asking how would the photocell correspond to the high intensity, that is approximately equal to 10 to the power of 5 watt per meter square. So it is red light of wavelength 6328 angstrom unit produced by a helium neon laser. Okay, look at the question carefully. Ultraviolet light of wavelength 2271 angstrom unit from a 100 watts mercury source irradiates a photocell made of molybdenum metal, right. If the stopping potential is approximately equal to 1.3 volt, estimate the work function of the metal and how would the photocell respond to a high intensity red light of wavelength 6328 angstrom unit produced by a helium neon laser, okay, and the intensity given in the bracket, which is approximately equal to 10 to the power of 5 watt per meter square. Okay, so now in this problem we have to calculate work function, and afterward we have to think about photocell respond, how the photocell is responding for high intensity red light of this much of wavelength and regarding this much of intensity. First we are writing the given values, so lambda value and then V naught value 1.3 volt, and afterwards W naught we have to find, okay. And you know Einstein's photoelectric equation we know, so from that equation we are writing, so we know that W naught is equal to Hc by lambda minus EV naught, and substitute the values because E value we know, H value we know, right. So 6.63 into 10 to the power of minus 34 into 3 into 10 power 3 into 10 power 8 divided by 2271 into 10 to the power of minus 10. So 1 angstrom unit is equal to 10 to the power of minus 10 meters minus E value 1.6 into 10 to the power of minus 19 into V naught is 1.3 volt. So if we complete this mathematical process, we will get it as 4.2 electron volt. So the work function is 4.2 electron volt. After that, threshold frequency nu naught is equal to W naught by H. This value is in electron volt, but the same value we are writing here in terms of joule. You know that 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joules. So 4.2 here, that is what if you convert this value into joules, we will get it as 6.64 into 10 to the power of minus 19 joules, and H value is constant, that is 6.63 into 10 to the power of minus 34 joule second, and complete this division, then we will get it as 1.0 into 10 to the power of 15 hertz, that is threshold frequency. Afterwards, for red light, right? So this one over. Now we are thinking about the second part of the problem, that is how would the photocell respond to a high intensity of this much of intensity and red light of wavelengths. This is the wavelength produced by helium neon laser. So we calculated threshold frequency also, and afterwards, for red light they have given wavelength as 6328 angstrom unit, that is equal to 6228 into 10 to the power of minus 10 meters. So now we are going to calculate the corresponding frequency for red light, that is nu is equal to c by lambda, no? So next 3 into 10 power 8 by lambda means this value. So finally we are getting the corresponding frequency for red light as 4.74 into 10 to the power of 14 hertz. 4.74 into 10 to the power of 14 hertz. Okay. This is the threshold frequency, and this is the corresponding frequency regarding the red light. So what is our conclusion? This value is less than, no? This value is less than this value. This value is, that is what? It will become like 10 into 10 to the power of 14, but this is 4.74 into 10 to the power of 14. So you decide which is less and which is more. This is less, no? So this value is less than, that is what? Nu is less than nu naught. Nu is less than nu naught. So that here, so there will be no photoelectric emission. No photoelectric emission with this red light. With this red light, howsoever high intensity may be. High intensity may be. So what can we say here? As nu is less than nu naught, so there will be no photoelectric emission with this red light, howsoever high intensity may be. Next question. That is what? 27th question. Monochromatic radiation of wavelength 640.2 nanometers from a neon lamp irradiates a photosensitive material made of cesium on tungsten. Full stop. The stopping voltage is measured to be 0.54 volts. If the source is replaced by an iron source and its 427.2 nanometer line irradiates the same photocell. Okay. Predict the new stopping voltage. Predict the new stopping voltage. So here through the comparison they have given stopping voltage at one instant. So he is asking the stopping voltage at the second instant. Okay. I will repeat the problem once again. Focus. Monochromatic radiation of wavelength, this much of wavelength, from a neon lamp irradiates a photosensitive material made of cesium on tungsten. Okay. The stopping voltage is measured to be 0.54 volts, right, full stop. The source is replaced by an iron source and its 427.2 nanometers line irradiates the same photocell. Predict the new stopping voltage, right. First, we have to write down the given values. Lambda 1, 640.2 into 10 to the power of minus 9 meters, and V01 as 0.54 volt, and lambda 2 as 427.2 into 10 to the power of minus 9 meter, because nano is 10 to the power of minus 9 now. V02 is equal question mark. Okay. From Einstein's photoelectric equation, we know that EV0 is equal to hc by lambda minus W0. This same expression we are writing for two different lamps separately. For neon lamp, EV01 is equal to hc by lambda 1 minus W0, and for iron source, right? For iron source, EV02 is equal to hc by lambda 2 minus W0. Okay. So therefore, just mathematically we are going to subtract V01 from V02. So V02 minus V01 is equal to hc by E into 1 by lambda 2 minus 1 by lambda 1. Now you substitute the values. So H value 6.63 into 10 to the power of minus 34 into, we have to write C value 3 into 10 to the power of 8. Okay. Afterwards, into 3 into 10 power 8 divided by 1.6 into 10 to the power of minus 19 E value into, in the bracket, 1 by lambda 2 as 427.2 into 10 to the power of minus 9 minus lambda 1 as 640, right? 640.2 into 10 to the power of minus 9. So you complete this mathematical process. Here we are getting 0.97 volt, 0.97 volt. Okay. So but finally he is asking to find V02, no? So V02 is equal to V01 and plus this value. So V01 already given, which is 0.54. So 0.54 plus 0.97 will give us 1.51 volt. 1.51 volt. Okay. Right. So in this class we discussed the 3 problems. Problem number 25, 26 and 27. Okay. In our next class we will continue with problem number 28. Thank you.